Hey everyone. So we're going to take all that knowledge that we have about solving equations and now we're going to solve inequalities. Okay? Solve inequalities. And you've been solving inequalities for a while now. 3x plus 1 is less than 10. And you subtract 1 and you get 3x is less than 9. And you divide by 3 and you get x is less than 3. Remember though, in our class, we're not going to use inequality notation. We're going to use interval notation. So 3 is not included and all the numbers less than 3 work. How do we represent this in interval notation? Negative infinity to 3, and because 3 is not included, this gets a parenthesis. If we had done this problem, this would be filled in, and therefore I would have a bracket there. Okay? So, solving inequalities. You've done it. This should be easy. I also want to encourage you, as I have, to think about things graphically. Okay? Think about things graphically. So if I have x squared is less than 5, think about this situation graphically. Don't think about this right now. Think about two different equations. Think about y equals x squared and y equals 5. And this is asking the question, when is the parabola below the horizontal line? Well, from here to here, from here to here, the parabola is below the horizontal line. Negative root 5, positive root 5. So from negative root 5 to positive root 5, 5 is bigger than this parabola. Great, and so our answer would be negative root 5 to root 5. We thought about that graphically, okay? But often it's either inconvenient to think about these things graphically or we're just not of a mind to. So this is our original problem, and what I want to tell you is that we need to first find critical numbers by changing the inequality to an equal sign and solving for x. Okay? So what that means is this problem becomes x squared equals 5. Then I'm supposed to solve, so I take the square root of both sides, and I remember when I take the square root of both sides, what am I supposed to do? That's right, plus and minus. So these are two critical numbers. I want you then to put critical numbers on a number line and test intervals. So we've got negative root 5, we've got positive root 5. So we've got three intervals here. Let's test them. What's a number between negative root 5 and positive root 5? I love the kids who say 1. 0. 0. So we go back to the original inequality. 0 squared is 0. Is 0 less than 5? Yes. Now I need a number bigger than root 5. Well, the square root of 9 is bigger than the square root of 5, and that's 3. So 3 squared is 9. Is 9 less than 5? No. How about over here? What if I plug in negative 3? Negative 3 times negative 3 is 9. Is 9 less than 5? No. So, and then I can even test the critical points themselves if I put in negative root 5. Negative root 5 times negative root 5 is 5. Is 5 less than 5? No. And that happens here as well. And so I end up with the only yes being in between negative root 5 and root 5. Okay? I know that you're not keen on using these critical numbers, but trust me, you're going to need to, especially when we do rational function inequalities. Okay, how about this one? X squared greater than or equal to 5. Okay, again, step 1, change from an inequality to an equal sign. Solve for x. These are critical numbers. Put the critical numbers on a number line. Test the intervals in the original inequality. Not anywhere else, not the equation, but the original inequality. If I plug in a 0, is 0 greater than or equal to 5? No. If I plug in a 3, 9, is that greater than or equal to 5? Yes. Negative 3. Negative 3 times negative 3 is 9. Is 9 greater than or equal to 5? Yes. And what about these points themselves? If I plug in square root of 5, square root of 5 times square root of 5 is 5. Is 5 greater than or equal to 5? Yes, it is. And that happens here as well. So these points are included, as are these. This point is included, as are these. So my solution to this problem is going to be negative infinity to negative root 5 with a bracket, union, bracket, root 5 to infinity. Okay? So our answers will be in interval notation. We're going to be using critical numbers. How do we find these critical numbers? Well, one of the ways is we turn that inequality into an equal sign and we solve. Okay? All right. Oh, and remember how before I was saying, hey, we could think about this graphically? Well, let's go back and think about that one graphically. There's y equals 5. And here's our parabola, y equals x squared. And remember, we had x squared greater than or equal to 5. When is this parabola above this horizontal line? Well, the parabola is above the line for x values from root 5 over, right? Because this parabola is up here, the line is down here, the parabola is above the line. That happens on the other side as well. The parabola is above the line from here down. So we've got these two intervals, and thinking about this graphically can be helpful. Okay, so today I want to focus on two types of inequalities. I want to do polynomial inequalities, and I want to take a second look at rational function inequalities. Okay, so let's start actually with some bell work. I know we're like 8 minutes into the video and now we're doing the bell work. So will you please, let's go back to graphing basics for a minute. Will you please graph x minus 2 squared times x plus 1? Okay, please graph that function. Oh, welcome back. So, when I think about graphing this function, I know I have an x-intercept at 2 and an x-intercept at negative 1. I know if I were to FOIL this out, subjunctive, I would have x squared times x, or x to the third, with a positive leading coefficient, so this end goes up and this end goes down. And I would be thinking about a bounce at x equals 2. So I'm going to pass through and I'm going to bounce. Okay. Any questions about graphing that one? Great. Let's go on. How about this one? X minus 2 to the third, x plus 1. Please graph this one. Okay. Did you still see that the x-intercepts were negative 1 and 2? But now that if you were to FOIL this out, you'd have x to the third times x, which is x to the fourth. So both ends go up. And did you notice you have a multiplicity of 3 at x equals 2? Remember, when we have an odd multiplicity and instead of passing straight through, like we do at x equals -1, a multiplicity of 3 is a wiggle. So I'm going to wiggle through there. Okay, so there's my graph. Great. Hopefully you've had experience with graphing with multiplicity and you're comfortable with this. And if you haven't, well, we'll come back and do more of it. Don't worry, it doesn't go away. All right, so why am I talking about this? Well, we're talking about polynomial inequalities. So what happens when I have x minus 2 squared times x plus 1 is less than 0? Well, I can think about this graphically, and I can think about this algebraically. Graphically, we're asking the question, when is this polynomial below the x-axis? Well, let's take a look at this polynomial. -1, 2. This polynomial is below the x-axis over here. And so I think my solution is -infinity to -1. Because I'm not going to be equal to here, this gets a parenthesis. Okay, so thinking about this graphically got me to this answer. Now, let's go back and think about it algebraically. Let's go through that little process that I showed a few minutes ago. Okay, first thing I want to do is find critical numbers. And I find critical numbers by changing the inequality to an equal sign and solving for x. So x minus 2 squared equals 0, x plus 1 equals 0, x equals -1. I take the square root of both sides, x minus 2 equals 0, x equals 2. So I've got these two critical numbers, -1, +2, and now I'm going to test these intervals in the original inequality. So I'm going to use 0, 3, and -2. When I plug a 0 in here, 0 minus 2 is -2. -2 squared is 4. 0 plus 1 is 1. 4 times 1 is 4. Is 4 less than 0? No. Plug in a 3. Oh, hey, by the way, some students think these always alternate. So if this is no, then these are going to be yes. Haha. Let's plug a 3 in. 3 minus 2 is 1. 1 squared is 1. 3 plus 1 is 4. 1 times 4 is 4. Is that less than 0? No. So sometimes the regions alternate, and other times they don't. So you actually have to test them all. If I plug in a -2, -2 minus 2 is -4. -4 squared is 16. -2 plus 1 is -1. -1 times 16 is -16. Is -16 less than 0? Yes. All right, and what about these numbers? If I plug in a 2, 2 minus 2 is 0. 0 times 3 is 0. Is 0 less than 0? No. And if I plug in a -1, -1 plus 1 is 0. 0 times 9 is still 0. Is 0 less than 0? No. So my solution then is -infinity to -1. So kind of what I want to say is, wow, doing this graphically so fast if I'm comfortable with the graphing. And if I think about it as a graphing problem. I can certainly do it algebraically. Most pre-cal teachers expect you just to be doing this algebraically. So I'm going to keep practicing algebraically, but I do want to say, this isn't bad when I think about doing this graphically. All right, so let's do one more of those factored polynomials. How about this one? X minus 2 to the third, x plus 1, and we're looking for greater than or equal to 0. Okay? So, which one do you want to do first? Graphically first? Algebraically first? Let's do algebraically. Remember what that looks like? Okay? Remember what we're supposed to do? We're supposed to turn the inequality symbol into an equal sign to find our critical numbers. I get critical numbers at 2 and -1. Now let's test the intervals. I'll use 0, 3, and negative 2. When I plug a 0 in here, 0 minus 2 is negative 2. Negative 2 to the third is negative 2 times negative 2 times negative 2, which is negative 8. Negative 8 times 1 is negative 8. Is negative 8 greater than or equal to 0? No. How about I plug in a 3? 3 minus 3 is 1, 1 to the third is 1, 3 plus 1 is 4, 1 times 4 is 4, and that is greater than 0. And if I plug in a negative 2, negative 2 minus 2 is negative 4. Negative 4 to the third is negative 64. Negative 2 plus 1 is negative 1. Negative 1 times negative 64 is positive 64. Is that greater than or equal to 0? Yes. And what about the critical points themselves? Well, because of this, those critical points are included. They are a yes. But if you're not sure, you can take a 2 and plug it in. 2 minus 2 is 0. 2 plus 1 is 3. 0 times 3 is 0. Is 0 greater than or equal to 0? Sure. 0 is equal to 0. So then my solution will be from negative infinity to negative 1. Since this is included, it gets a bracket, union from this point out, so 2 to infinity. Okay, that was us doing this problem algebraically. Now, let's think about this graphically. I've got a fourth degree polynomial with a positive leading coefficient, so both ends go up. And because of this multiplicity of 3, I know I'm going to wiggle over here and pass straight through over here. And then, what does this say? When is this polynomial above or intersecting the x-axis? Well, here. Here the polynomial is above or intersecting the x-axis, and here the polynomial intersects the x-axis, and for all these x values, the polynomial is above the x-axis. And so I get negative infinity to negative 1, union 2 to infinity. Okay? I will say that it's really, really important when you do these problems algebraically to think, because here's what happens. When students don't follow my recipe for solving this, and they say, okay, I take the square root of both sides, and then they're all proud because they say, I remembered the plus and minus, Mr. Kukla, it's all good. And so then they get to subtracting that 2, and they have negative 2 plus or minus 5, which means x is going to be bigger than 3, and x is going to be bigger than negative 7. And they say, these are my answers. And I say, really? And then they say, yeah, look, I've got negative 7, I've got 3, I've got x is bigger than that, and x is bigger than that. And then they say, well, 3 can't be included. And then they say, does my answer go from negative 7 to infinity, or just this part over here where they overlap? And the answer is, all of those students are wrong. Yep. So let's now do this the way I said to do it, which was that you'll have an equation here. Before you take the square root of both sides, you're looking for critical numbers, so you turn this into an equation. You solve the equation. You do want the plus and minus 5. You are going to subtract 2. So you'll get x equals 3 and negative 7. These are critical numbers. Let's put the critical numbers on the number line. Now let's test the intervals. Okay, I'm going to use 4, 0, and negative 10. If I plug a 4 into the original inequality, 4 plus 2 is 6. 6 squared is 36. That's bigger than, yeah, that's great. Mr. Google, that's what I had. Yes, I know. But wait, if I plug in a 0, 0 plus 2 is 2. 2 squared is 4. Is 4 greater than 25? No. So that's not included. What if I plug in a negative 10? Negative 10 plus 2 is negative 8. Negative 8 squared is 64. Is that greater than 25? Yes. see? Yes. And why I'm pausing dramatically there is because remember when we did it the other way and we ended up with x is greater than -7 and x is greater than +3, and we were looking at that on the number line and we said these, and maybe it's just the overlap, or maybe it goes from 7 on. And what about over here? We've got nothing over here. We don't think this is part of the solution at all, and look, it is. So, don't forget to change that inequality to an equal sign. Find your critical numbers, put the critical numbers on a number line, and test the intervals. It'll really cut down on a lot of mistakes. My answer here should be -infinity to -7, parentheses union, 3 to infinity. Why are these parentheses? Because there's no could be equal to here. Okay, so these points are going to be no's if you check them. All right, so please, please, please turn the inequality into an equal sign, find the critical numbers, put the critical numbers on a number line, and test the intervals. All right, next. How about x squared plus 4x plus 4 is greater than or equal to 9? Now, with this one, you can do this one of two ways. One way is to subtract 9 from both sides. Another way is to recognize that you have x plus 2 squared here. Oh. Do both ways work, Mr. Cuckoo? Because I didn't see this was x plus 2 squared, so I'm not thinking I'm going to take the square root of both sides. I'm thinking, okay, x squared plus 4x plus 4 is equal to 9, becomes x squared plus 4x minus 5 when I subtract 9 from both sides. And that factors as x plus 5 and x minus 1. And so I know that x equals -5 and x equals +1. These are our critical values. We put the critical values on the number line, and we test values in each of those intervals. If I plug in a 0 in the original inequality, 0 plus 0 plus 4 is 4, is that greater than or equal to 9? I plug in a 2. 4 plus 8 is 12, plus 4 is 16, is that greater than or equal to 9? Yes. And if I plug in a -10, -10 times -10 is 100. 4 times -10 is -40. 100 minus 40 is 60. So I get 64, and that is greater than 9. So that's a yes. These points, the critical points themselves, because of this, are yeses. And so my answer is going to be -infinity to -5, union 1 to infinity. Okay? Hey, what if we had seen that perfect square? Well, so that would be x plus 2 squared equals 9. Then we take the square root of both sides. X plus 2 equals plus and minus 3. X equals -2 plus and minus 3. So I know that x equals 1 or -5. I get the same answers. So I have a lot of flexibility in which approach I want to take, because I know a couple of approaches, but I'm always going to turn the inequality to an equal sign, find the critical numbers, put the critical numbers on the number line, and test those intervals in the original inequality. Okay? All right, how about this one? X squared plus 2x less than or equal to 3. Will you please solve this one? Pause the video, come back when you're done. Hey, welcome back. So my hope is that you did not do this. Because if you did that, you haven't been paying attention. You haven't been watching enough videos. You haven't been taking the notes on the video. When I see a power greater than 1, I must move this over. Okay? But even before that, I'm going to start with turn that inequality into an equal. Then I'm going to subtract the 3. Now I'm going to factor. to find critical numbers at -3 and +1. Now, let's test them. When I plug a 0 in, I get 0 is less than 3. That's a yes. If I plug in a number over here like 2, 2 squared is 4, 2 times 2 is 4, 4 plus 4 is 8. Is that greater than or equal to 3? No. How about a -4? 16 minus 8 is 8. Is that greater than or equal to 3? No. And what about these points? Well, because of that symbol, that's a yes, and that's a yes. So it looks like my solution goes from -3 to 1 with brackets. Okay? Okay. How about this one? X to the third plus 2x squared minus 4x minus 8 is less than 0. You should give this a try. What do you mean you don't know what to do? Anytime we have an inequality, turn it into an equal sign. Once we have an equal sign, you see 4 terms. What could you do over there? That's right, factoring by grouping. Okay. So I'm going to have x to the third plus 2x squared minus 4x minus 8 equals 0. And then I'm going to factor by grouping. So I'm going to pull out an x squared and have x plus 2. And I'm going to pull out a -4 and have x plus 2. Now I see these x plus 2's. I can take out an x plus 2 from each of them. What's left over? Here, an x squared, and then a -4. Now this is a difference of squares, and it factors as x plus 2 and x minus 2. So my critical numbers are -2 and 2. So let's put those critical numbers on the number line and test the intervals. -2, 2, and remember this was x to the third plus 2x squared minus 4x minus 8 is less than 0. I think it was less than. Okay, so if I plug in a 0, 0, 0, 0 minus 8 is -8 less than 0, yes. If I plug in a 3, 27 plus 9 times 2 is 18 minus 12 minus 8. So 30, 45 minus 20 is 25. Is that less than 0? No. And if I plug in a -3, that becomes a negative, this stays positive, this becomes a positive. So now we've got 30 minus 35. I get -35, that is less than 0, so that's a yes. So what about at -2? Well, if I plug in -2, I'm going to have -8. 4 times 2 is +8. I'm going to have 8 minus 8. I'm going to get 0 is less than 0. No. Oh, so it was equal to, yes. Okay, so that's a yes, and that's a yes. So, an answer then is -infinity to 2. Now, let's think about this. This was x plus 2 squared and x minus 2 less than or equal to 0. So we've got a third-degree polynomial with a positive leading coefficient. X-intercepts at -2 and 2, and at -2 I have a bounce. So this is my graph, and I'm saying when is this polynomial below or intersecting the x-axis? Well, there, which is here. Now, if I had changed this inequality to that, then this point is no longer included. And this point is no longer included. So if I had this less than instead of less than or equal to, this wouldn't be my answer. But I would have -infinity to -2 union -2 to 2. Okie doke. Okie doke. Alright, so How about one, maybe two more polynomials, and then we'll look at a couple of rational functions. So how about this one? 4x to the third minus 12x squared greater than 0. Will you please solve this inequality? Pause the video, come back when you're done. Okay, so did you remember to turn this into an equal sign? Did you then remember to factor out the GCF for x squared? Now I'm looking for critical numbers, so I set these factors equal to 0. I put these critical numbers on the number line and test the intervals in the original inequality. So I'm going to use 1, -1, and 4. When I plug a negative 1 in, -1 times -1 times -1 is -1 times 4 is -4. -1 squared is 1, 1 times 12 is 12. So -4 minus 12 is -16. Is that bigger than 0? No. Now I'm going to plug in a 1. 4 minus 12 is -8. Is that greater than 0? No. And what about 4? So 4 to the third is 64, times 4 is 256. And then 4 squared is 16. 16 times 12, is that 192? 16 times 12 is 192. So I get 256 minus 192. Is that greater than 0? Yes, that's possible. Okay. And if I plug in a 0, 0 minus 0 is 0. Is that bigger than 0? No. And the same thing happens here. So my answer here is just going to be 3 to infinity. Be careful. Some people do all this work beautifully, and then they come to this point where it's time to write the answer, and they put from 4 to infinity because they used 4 as a test point. No, these aren't test points. These are critical numbers. Your critical numbers go in your solution, not the test point. The test point is arbitrary on that interval. Okay? All right, now does this make sense graphically? Let's think about it graphically. So we factored over here. We've got an x-intercept at 0 and at 3. And it's a third-degree polynomial with a positive leading coefficient. And I'm bouncing at 0 and passing through there. When is this polynomial above the x-axis? Just over here, which is why we said that. All right, let's take a look at rational functions now. 2x plus 1, 3x minus 4, greater than 1. Now, with rational equations, we start off the same way, where we say, okay, 2x plus 1, 3x minus 4 equals 1. And then just like we did in the solving videos that you watched, we're going to multiply by 3x minus 4 and 3x minus 4 to cancel out that denominator. We get 2x plus 1 plus 3x minus 4. I get 5 equals x. So I get one critical number. No. It turns out that's one of the critical numbers. Remember, critical numbers are where something critical is happening on the graph. Something critical is happening on this graph. There's a vertical asymptote at positive 4/3. And the only way I know that is because that's when this denominator is equal to 0. So, critical numbers come from solutions to equations. That's what we spent most of this video doing, but also when denominator equals 0. So I get two critical numbers here. I get 3x minus 4 equals 0, 3x equals 4, x equals 4/3 is my second critical number. All right? Most people forget this, so I hope you please make a note of it. All right, so my critical numbers were 4/3 and 5. So let's test 0, 2, and 10. Same way, I'm plugging a 0 in here, and I get 1 over -4. Is -1/4 bigger than 1? No. How about a 2? 4 plus 1 is 5. 6 minus 4 is 2. Is 5/2 bigger than 1? Well, that's 2.5. That's bigger than 1. What if I plug in a 10? On top, I get 21. On the bottom, 30 minus 4 is 26. Is that greater than 1 or less than 1? That's less than 1, so that's no. And the points themselves, well, this is also very interesting. Let's even do this. Okay, so let's plug in a 5. 5 times 2 is 10, 10 plus 1 is 11. And on the bottom, 15 minus 4 is 11. And so that becomes 1. Is 1 greater than or equal to 1? Yes. And so people want to say, well, look, Mr. Cooper, that's included because of the equal sign. Yeah, Let's try 4/3 then. 2 times 4/3 is 8/3. 8/3 plus 1 is the same as 8/3 plus 3/3, or 11/3. Is 11/3? Oh, over. We have a denominator. 4/3 times 3 is 4. 4 minus 4 is 0. I have a 0 in the denominator, everybody. Can that point be included? No. But Mr. Cooper said equal to. I know. Not all critical numbers are created equal. It turns out that any critical number that comes from a denominator, that will always be no. It doesn't matter whether I have an equal to or not here. Denominator critical numbers are always no, because denominator critical numbers are always going to turn the denominator into 0. So that's always a no. Always a no for denominator critical numbers. So yeah, it might be worth your time. Not just testing the intervals, but the points as well. Ooh, excuse me, hiccups. So what's the solution, Mr. Cooper? All right, well, so I've got a no there. 4/3 to 5, and 5 is included. That's my solution, okay? That's when this rational graph is above or intersects the line x equals 1. Please note, bracket because equal to, but wait, parenthesis because denominator. All right, so let's have you try one of them. How about x plus 12 over x plus 2 is less than 4? In fact, we'll do less than or equal to 4. Pause the video, give this one a try, and see how it goes. Okay, welcome back. So I'm going to start with equals 4. I'm going to multiply both sides by x plus 2 and cancel out the fraction. And then I'm going to solve for x. And I get 4 equals 3x, x equals 4/3, right? Because I'm going to subtract 1x to get 3x. I'm going to subtract 8 to get 4. So that's one of my critical numbers. Is it my only critical number? Oh, look, a denominator. X plus 2 equals 0, so x equals -2 is another critical number. So I have -2, and I have positive 4/3. Let's test those intervals. Okay, remember we test in the original inequality. So what numbers? How about 0? How about 2? How about -3? Okay, if I plug in a 2, 2 plus 12 is 14. 2 plus 2 is 4. 14 over 4. Is that less than or equal to 4? Well, this would be 16/4. So 14/4 is in fact less than 16/4. That's a yes. What about 0? If I plug in a 0 here and a 0 here, I get 12 over 2, which is 6. Is 6 less than or equal to 4? No. And -3. -3 plus 12 is 9. And negative 3 plus 2 is negative 1. Is negative 9 less than or equal to 4? Yes. And how about the critical points themselves? Well, if I plug in a 4 thirds plus 36 thirds is 40 thirds. And on the bottom, 4 thirds plus 6 thirds is 10 thirds. And if I do the flip and multiply, I get 4. Is 4 less than or equal to 4? Yes. But if I plug in a negative 2, what happens in the denominator? Negative 2 plus 2 is 0. I put 0 in the denominator. This critical number came from a denominator, so any critical number that comes from a denominator is always going to be no. So my solution here is negative infinity to negative 2 with a parenthesis, and then union 4 thirds to infinity. Okay? Okay. Well, I hope this was helpful. We talked about a bunch of important things. Please find critical numbers. Remember, you want to set that inequality, change that inequality, whatever that inequality is, to an equal sign, and solve that equation to find those critical numbers. But remember, critical numbers not only come from solutions, but they also come from what turns this into 0. All right, so be looking for those in tonight. I notice that these problems seem to involve a lot of the skills that we've already been learning in this Algebra Basics unit. I have to do factoring here, and it really helped to think about these things graphically as well. So all this stuff is building on itself. Please, this is a cumulative class. You really need to make sure you get those earlier concepts, and if you're not sure of them, don't give up. Reach out. Ask me questions. I'm waiting for you to ask questions. Send them in GroupMe. Use the main group. If you're too shy to use the main group, send me a direct message. But here's the thing. If you're suffering and you don't know how to do this stuff and not asking questions, you're probably going to fail the class. I mean, some people go to all kinds of links rather than ask the teacher questions. They'll spend hours watching YouTube videos that are only a little related to what we're talking about, just in hopes that they'll find an answer. When really, if they just asked their teacher, I would be happy to answer the question. Please, it would be such an efficient use of your time. Please ask questions. Ask them in the GroupMe. Ask them in our Zoom sessions. Please, please, please ask questions. All right. Have a nice day, everyone.